Alright, so we're looking at number 6 here on this assignment with the final position of an object that starts at 7.1 meters. I'm going to make this a little bit bigger. I don't know about you guys, but it looks small to me. Meters, it moves the velocity of this for 3.1 seconds, and they give me a direction of negative direction on that velocity. All right. And they've already included the units here that they'd like it in meters. All right, so this is number 6. Alright, so number 6, we got the object moving. We need to write our y. Anybody have a favorite text color?
I like blue.
You like blue?
Yes.
We'll do blue. There we go. Okay. So, I don't know, let's start off simply. Let's start off, obviously. The faster the object moves, the further, more displacement it will have in a given time. Pretty straightforward, but true. This object is moving negatively, so the displacement will be negative. Anything else that I need to include in there? Where's my... Stop. Oh, it's Monday. Alright, so here we go. Folks, remember, you don't need to do this problem with me, but if you're going to talk, just kind of go over the other side of the room. So those who want to follow along can. Alright, either way, just, you know. Alright, so I think that's good for my y. It's a fairly straightforward problem. Alright, so now I'm going to move on to my how. And I want to make sure I start with that valid physics equation. So I'm going to get up my equation sheet. And I'm looking for an equation that has to do with position and velocity and time. And so I'm going to pick this one right here. And by pasting that in, oops, missed it. By pasting that in, that counts as my starting with valid physics equations. And now I need to pull information from my problem. My problem tells me that I want to know the final position. So that would be D, where I end up. So I don't know that, so I should probably we'll write in D. I'm going to remind myself that it's a vector, so it can be positive or negative. It tells me D naught, tells me where I start, is at 7.1 meters, and they really mean positive 7.1. But that's understood, so we can put that in. Plus, tells me my velocity is negative 1.1 meters per second. And then it tells me the amount of time that elapses is 3.1 seconds. And before I did any math, I would make sure that my units align. You know, my position is in meters, my velocity is in meters per second, my time is in seconds. So all my units align. You guys can do the algebra, right? After that? Or the arithmetic, whichever way you look at it. Right? Questions on the how or the why for that one? Excellent. All right, on to number 5. Got 2 cars traveling parallel on a 2-lane road. Choose the first graph to show the figure answer the question. Use time from the graph indicated by the letters. So we want to write up our y for this, thinking about the meaning of the terms in the question. So at which times do the 2 cars pass each other? So I think it'd be good to start off with showing our understanding of what we mean when they pass each other. So what has to be true to pass the other car? Think about you're on the highway. What do you mean by I pass to them?
Right, on the opposite.
Okay. Maybe, yeah, you might need to, unless they were going the opposite way.
You're going
Right, you have to meet them. You have to be at the same place at the same time. So that's what I'm going to start off with. It's just showing my understanding there. To pass the other car, we must at one point be at the same place at the same time. Oops, I didn't. Alright, let's see what else. And then that's part A. And then how can we tell the direction from a position time graph? How can we tell the direction the cars are traveling? Well, let's see, the direction, the slope of the position time graph is the velocity. So the direction of travel is shown by the velocity. Okay. I think this one's going to be more y than how. Which of the letter times if any, does car number one momentarily stop? I'm going to say the slope of the car one's position graph is constant, so it is moving at a constant velocity. Part D, which one is part 2 momentarily stop? Part 2 would be stopped when the slope of its position time graph is 0. So I'm showing that I understand the root to these. At which other times are the cars moving with nearly identical velocities? The two cars would have the same velocity. Keep doing that. Velocity when the slopes of their graphs are the same. So I think this one really comes down to understanding the all those terms and everything that they had in there. So